Did you know that the entire universe is glowing? Not with stars or galaxies, but with the faint echo of its birth, a cosmic whisper from over 13 billion years ago. This is the cosmic microwave background radiation, and it's one of the most powerful pieces of evidence for the Big Bang. But here's the real question. Does this mean we've the Big Bang? Or is science more about evidence than absolute proof? Let's dive in. Welcome to the ultimate science debate. Is there such a thing as scientific proof? Spoiler alert, science doesn't deal in absolute proof. Instead, it's all about evidence, theories, and constant refinement. Today, we're exploring three mind-blowing concepts. 1. The cosmic microwave background radiation and the Big Bang. 1. Quantum entanglement and its bizarre implications. 1. String theory and the possibility of extra dimensions. But before we get into the nitty-gritty, let's talk about why this matters. Understanding how science works and what it can and can't tell us is crucial in a world filled with misinformation, so buckle up. This is going to be a wild ride. Let's start with the cosmic microwave background radiation, or CMB. Discovered accidentally in 1964 by Arno Penzias and Robert Wilson, the CMB is the oldest light in the universe, a faint glow that fills the cosmos. But why is it such a big deal? Well, the Big Bang Theory predicted that the early universe was incredibly hot and dense. As it expanded and cooled, it left behind a faint afterglow, the CMB. And guess what? The CMB's temperature, uniformity, and tiny fluctuations match the predictions of the Big Bang model almost perfectly. But here's the kicker. The CMB isn't just a snapshot of the early universe. It's also a treasure trove of information about the universe's composition, age, and even its fate. Missions like NASA's COBE map and ESA's Planck have mapped the CMB in stunning detail, revealing secrets about dark matter, dark energy, and the universe's geometry. So is the CMB proof of the Big Bang? Not exactly. It's incredibly strong evidence, but science always leaves room for new discoveries that could change our understanding. Now let's shift gears to something even weirder: quantum entanglement. Imagine two particles that become linked so that no matter how far apart they are, changing one instantly affects the other. Einstein called this spooky action at a distance, and it challenges everything we know about reality. Experiments have confirmed that entanglement is real, and it's not just a quirk of quantum mechanics, it's a fundamental feature of the universe. But what does this mean for our understanding of space, time, and causality? Some scientists believe entanglement could be the key to quantum computing, while others think it might hint at hidden dimensions or even a deeper structure to reality. But here's the thing. While the evidence for entanglement is overwhelming, we still don't fully understand it works. And that's the beauty of science. It's a never-ending quest for answers. Finally, let's talk about string theory, a bold idea that suggests everything in the universe is made up of tiny, vibrating strings. But here's where it gets really wild. String theory requires extra dimensions, up to 10 or 11 of them. Why? Because the math only works if these hidden dimensions exist. But here's the catch. We have no direct evidence for them. String theory is not a proven fact. It's a framework that could potentially unify all the forces of nature, but until we find experimental evidence, it remains in the realm of speculation. So is string theory science? Absolutely. But it's also a reminder that science is a process. It's about exploring ideas, testing them, and being willing to revise or abandon them if the evidence doesn't hold up. So what do you think? Is the CMB enough to convince you of the Big Bang? Do you believe in quantum entanglement? Or does it sound too sci-fi to be real? And what about string theory? Could there really be extra dimensions hiding in plain sight? Let me know in the comments below. And if you're enjoying this deep dive into the mysteries of the universe, don't forget to hit that like button, subscribe, and ring the notification bell so you never miss out on our next exploration. Trust me, you won't want to miss it. Speaking of next time, we're diving into the mind-bending world of black holes and dark matter. What happens inside a black hole? Is dark matter real? Or are we missing something fundamental about gravity? Let's find out together. And if you're craving more cosmic mysteries right now, check out our video on the Fermi paradox. Why haven't we found aliens yet? The link is in the description. Thanks for watching. And remember, the universe is full of questions. Let's keep exploring. Science isn't about proving things once and for all. It's about asking questions, gathering evidence, and being open to new ideas. The cosmic microwave background, quantum entanglement, and string theory are all pieces of a puzzle we're still putting together. So, here's my final question for you. What do you think is the next big discovery in science? Let's keep the conversation going in the comments. Until next time, stay curious.